1. Go to Accidents tab. You will see that it contains on columns A and B a detailed list of 5,000 accidents recorded daily starting on January 2016 until December 2020. Column B reveals the dollar amount of each accident's loss. 2. Column E on Accidents tab summarizes a monthly count of accidents per month. Since we will be calculating a monthly profit and loss statement, it is important to summarize information monthly. Therefore, information is summarized here also for the months between January 2016 and December 2020. Observe that the special Excel array function, frequency, does the job to summarize accident losses per month. For example, view cell E2 with the formula equals frequency, open parenthesis, range A2 through A5001, fixed, comma, range D2, D61, fixed, close parenthesis. It counts how many accidents are there per month from the range A2 through A5000, categorized according to the intervals located on range D2 through D61. 3. Go to Model tab to start adding calculated parameters to the model. The insurance industry frequently uses the log normal distribution to model their payments data. These types of payment data are typically very highly positively skewed. It is one of the reasons it is often used. A log normal distribution requires two parameters calculated directly from the loss or accidents dataset: the mean and the standard deviation. 4. On cell C2, calculate the mean number of accidents per month with the formula equals average, open parenthesis, accidents E2 through E61, fixed, close parenthesis. 5. On cell C3, calculate with the Excel formula equals average, open parenthesis, accidents B2 through B5001, fixed range, close parenthesis. The mean severity of accidents. 6. On cell C4, calculate with the Excel formula equals STDEV, open parenthesis, accidents B2 through B5001, close parenthesis, fixed, the standard deviation of accidents. We will now introduce the Poisson distribution to model the monthly frequency of accidents. 7. Place your cursor on cell C5 and type equals DT Poisson, open parenthesis, C2, close parenthesis. This will show you as a comment the following chart on this distribution function. As you can see, we are making a reference to cell C2, which contains the mean number of accidents and stands to be lambda, the only required parameter of a Poisson distribution. A Poisson distribution always returns only integer values, with the mean and variance equal to its only parameter lambda. It is usually used to describe, for example, number of individual events that occur in an interval of time when the events are occurring at a constant rate, the number of customers arriving in a queue, the number of accidents on a road, or the number of imperfections per meter of carpet, the number of items in a batch of random size, the number of items needed from an inventory, the number of periods, months, or days a device is out of service, or, like in this case, the number of claims in an insurance policy. It assumes that the time between failures has an exponential distribution, which means the number of failures occurring in a small interval of time is constant. 8. On cell C6, we proceed to create the log normal distribution for the severity of any given accident. We have previously defined on cells C3 and C4, respectively, the two parameters required for this distribution, the mean and the standard deviation. Type on C6 equals dt log normal, open parenthesis, C3, comma, C4, close parenthesis. This will show you as a comment the following chart on this distribution function. 9. As stated before in the case, the average monthly premium charged per client is of $75, with a standard deviation of $5. On cell C7, we write the following function, equals dt normal, open parenthesis, 75, comma, 5, close parenthesis. This will create such a normal distribution for this variable. This will show you as a comment the following chart on this distribution function. As stated before in the case, every month new customers come in and some exit, leaving a constant average number of monthly customers at 2,200 with a 5% coefficient of variation. 10. On cell C8, we write the following function. Equals dt normal, open parenthesis, 2200, comma, 110, close parenthesis. This will create such a normal distribution for this variable. Remember, a coefficient of variation is the expression of standard deviations as a proportion of the mean. Therefore, a 5% coefficient of variation with respect to a mean of 2200 means a standard deviation of 2200 times 5% equals 110. This variable should be looking like this on its comment chart. 11. On cell C9, write 400 as the value of the individual deductible.